Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about density curves. Here is a relative frequency histogram on heights of high school students. You'll recall from previous lessons that a relative frequency histogram has bars that represent the proportion of students that are within that interval instead of the count or frequency of students that are in that interval. So each of these bars is the proportion of students that fall within each interval. This histogram is a little bit messy, and we would suspect that a lot of data in nature is messy. In order to make it a little cleaner and easier to work with, we're going to model it with a density curve. A density curve is a curve that models an actual distribution. You'll note here that it does not perfectly follow every single bar as it goes across the graph, but it models the general shape of the distribution. This is particularly helpful with data sets that contain a large number of data values. Since the height of all these bars represented proportions of the data set, the area underneath the density curve also represents proportions. So the area under the entire curve would add up to 1 or 100% of the data. We could use the density curve to find proportions of the data set, say, that fall between 60 and 65 inches. That would represent the proportion of students whose height is between 60 and 65 inches. Or if we were curious about the proportion of students who are greater than 70 inches tall, we could find this area under the curve over here. To summarize, density curves are curves that model an actual distribution. The area underneath it adds up to 1. Thank you for watching this video. I hope you found it helpful. I'll leave you with this quote by Walter Hagen. Have a great day.